Good morning, good afternoon. How's everybody doing? Welcome. It's a very bright light up here, so we're
Yeah,
gonna
that light is.
see how this goes. But Freddie, you want to go ahead and kick us off?
Hi.
Oh well, first of all, if you are not supposed to be here talking about analytics architecture patterns in Fabric, then you might want to leave. Otherwise, that's where we're going to be for the next 50 minutes here. So
Yeah. Firstly, thank everyone for joining us on the session. The intent of the presentation that we have today is talk about some of the architecture patterns and things that we see along the history of analytical workloads, and how can we actually implement those on Fabric. Not only that, we're going to talk as well towards some of drawbacks of different architectures and how we can overcome some of those drawbacks with technology and how other architectures overcome those drawbacks as well. So firstly, let's present myself. My name is Freddie Santos. Work for Microsoft for pretty much 12 years, and I work with different flavor of products. I work with SQL Server, Azure DW, Synapse Analytics, and now I'm part of the CAT team for Microsoft Fabric. As a good Brazilian, I love soccer, so soccer is with me. My kids are more American, so they are more on American football, but I still soccer. And I'm a geek, so I love manga, animes, anything, gaming, RPG. So anything like geek stuff, you can count on me for a good session.
So I'm Brad Schacht. I'm also principal program manager on the Fabric Cat team. So I spent years doing consulting before coming over to Microsoft. So I built like BI solutions, data warehousing, that sort of stuff. Was a cloud solution architect over here for about 5 years before moving over to the Cat team a couple years ago. So anything and everything, data warehousing, BI, modern analytics, all that kind of stuff is everything that I do on a daily basis. So.
Okay, so as I mentioned, we are going to talk about some of the analyticals. Yes? Sorry, I can't. Okay, can you? Okay. So we're going to talk about some of the analytical solutions, as I mentioned, and we're going to talk as well about Microsoft Fabric, how Fabric actually try to solve some of these patterns of architectures. And then we're going to dive deep on some of those architectures, such as like data warehouse, data lake, data mesh, and we're going to see some of those patterns and how we can actually achieve those architectures on Fabric. So, but first, let's set the stage for what is an analytical workload. So when we are actually what problems we're trying to solve with analyticals, right? And the first one is we are always looking towards to define what happened. When we started looking on analytical workloads in the beginning, we were always trying to answer what happened for a given state of the business, a given state of weather, or anything, any type of things that we're trying to understand what happened. But with the evolution of the analytical workloads, we also start to see that what happened was not enough. We now need to diagnose, we need to describe and say why that happened. So then the complexity of the workloads start to evolve not only why, not only with what, but then we start to try to predict. So what could happen given the desired state with the numbers and data that we have? So with this type of workloads and with these questions, it is getting more and more complex, the workload across the last decades, how we actually attach and complete analytics. And not only that, then we start to overcome and start to look for some of those challenges, and we need also to do prescriptive work. So what it means, instead of only what could happen, what should happen, we need to answer why and what. So this type of workloads and complexities start to pretty much set the stage for any type of analytical workloads. But not only that, with the evolution in the types of workloads, we saw relational database, as we're going to see, we see a lot of different patterns, but big data came to the stage. And with big data came to the stage, we start to deal with these 5 Vs that become like a pattern for all the most modern architectures on data analytics. We need to deal with volume. And we jumped from the gigabytes to the terabytes. Now we're talking about petabytes of data. We have customers with multi-petabytes of data in analytical workloads. But we need to deal with multi-terabyte, multi-petabyte database with performance. It needs to be fast. And we still need to do all the predictive, prescriptive, answer why and what we are doing. And then we start to become even more complex because some of those questions need to be answered with speed, with performance, with a high volume, and then with a variety of type of data. Before, we were talking about the majority of relational databases. Now we're going to have data from streaming, data for sensors, IoT, tweeters. So everything that we need to deal, it's a very different objective and a different type of data that we need to deal with one subsystem of compute. And that was very hard when we're talking about that. Not only that, because we're talking about these 3 Vs, but as we are seeing these 3 Vs, the variety, we need to deal with data quality. Because just having data stockpiled is not enough for us. So we need to have quality on the data in order to process that in an optimized way to mean something for our business. And ultimately, we need to produce value. Just having data for the sake of having data is not enough for the business anymore. So we need to produce value from that. So when we're talking about big data and all these patterns, we are going to see on Fabric how we can actually achieve some of those architectures and how we can answer some of these challenges on those paradigms. And with that, I just want to set the stage with Microsoft Fabric, because as we saw on the keynote, we have Fabric as a platform, a SaaS platform that can actually plug on every single type of workload that you can have for a big data solution. So you can go from the streaming processing all the way to the regular batching and data warehouse. And we are going to see over this presentation how we can actually build solutions with different components within Fabric that can lead for that solution.
All right, so before we get into a couple of these different design patterns, quick show of hands, based on, kind of just get an idea, what do you all do on a daily basis? So if you are a DBA and you're brave enough to raise your hand in an analytics session to say that you're a DBA, are you out there, anybody? 2 DBAs, okay, perfect. Who's a Power BI developer? Okay, who is a solution architect? All right, perfect. Who's like a data engineer? You do like Spark and all that kind of stuff? Okay. Who did not vote? All right, what is your role? What? Your role is person I can't hear in the back of the room? I'm sure we've got you covered. We'll come back and get you later. Okay. Well, that helps just because we want to make sure we kind of talk at the right level of depth for some of these things as we go through here. So as we look at the analytics landscape, if we go all the way back to the 1900s, when our journey really begins, I feel old being able to say that like IBM first published like a white paper in 1988, and they first used the term business data warehouse. And like I was doing this, and I was like, well, I'm going to be able to say, no, I wasn't alive in 1982 to be able to make fun of everybody for being old in here. But now I'm the old guy because I was alive whenever they first came up with this. But so who out here, who has built a data warehouse? Okay, keep your hand up, keep your hand up. Did the project go well? Keep your hand up if it succeeded. Okay, good, all right, cool. So the reason why we build data warehouses is to create that single version of the truth, right? We want to bring all the data from all these different source systems, consolidate them all into one location, get that view across the business, right? It helps us answer some of those looking back questions that Freddie was just talking about a moment ago. And we usually use a process called ETL, or extract, transform, and load, which we'll talk a little bit more about those processes in a bit here. And more often than not, most of the folks who raise your hand, you probably have used the Kimball method. So you probably built like a star schema, right? Facts, dimensions, and joined all of them together. So cool. The challenges with those, and the reason why I asked people to keep their hand up if you actually had a successful project, was oftentimes what we saw was those projects failed because they took a really long time to implement. So maybe you built a smaller warehouse and those were easy to implement and successful or something like that. But oftentimes in really large organizations, that was a big challenge with those. The other problem is data integration across all your systems. So like we've got data in a SQL Server system over here and an Oracle over there and DB2 over here. And then we want to bring all those things together. There's a lot of stuff that goes into making sure that those can all work together. And what we're trying to do as we move into the cloud and everything, obviously, and with Fabric, is make those things a little bit easier. And performance over time becomes a problem because as we move from those gigabytes to petabytes um, worth of data, it becomes harder and harder to process that data and maintain a good performing system. So just in general, if we look at what the data warehouse looks like on Fabric, it actually looks very similar to the environments that you're used to seeing. You kind of just replace that SQL Server icon. Hopefully it's a SQL Server icon. You just replace that SQL Server icon with a Fabric data warehouse, and you're pretty much good to go. Now, obviously, that is a very simplistic view of the world. You have to make sure that your T-SQL is compatible and all that kind of stuff. You got to be able to use something to get the data into the cloud if you happen to need to be, if you happen to have data that's on-prem and everything right now. But essentially, this is where we would look at things landing. I bring up we'll talk about scale here in just a moment again, but just to give you an idea as to the scale at which we can run things on Fabric, the data warehouse specifically, or the Lakehouse SQL endpoint even for that matter, if you happen to be one of the folks out there that wants to use that Lakehouse type architecture, which we'll touch on in a moment. But we started to run some benchmarks on Fabric, comparing it to Azure Synapse Analytics. So who in here has used Azure Synapse Analytics? Okay. Oh, that's pretty good size of the room. So on Synapse, like we took a 10 terabyte TPCH data set, and we started to run that on both platforms, okay? Well, we actually were able to match the performance on Fabric with an F64. That performance matched what on Synapse was actually like a DW3000, if I recall correctly. So the price difference between those, you're looking at 1/8 the cost to run that same workload on Fabric compared to what you were running it on the Synapse dedicated SQL pool. If you then took and ran that with like 10 concurrent users, the Synapse pool actually failed. Like it filled TempDB, okay? But it actually succeeded even on the F64 over on the Fabric side. So we can run very large workloads on Fabric, even at relatively small scale compared to what we could do with the Synapse side of things. And the way that we end up getting that performance, and the reason why that happens, is because of the way that we've changed the architecture and redone the resource allocation. So what happens when you go to run a query on Synapse is it gives you a cost optimization, and it says, here's the query plane that I want to run, and it goes and runs it across all the nodes in the background. Okay, if you're running a DW7500, then you've got 15 nodes behind that, and you always have 15 nodes, no matter what. Okay, but over here on the Fabric side, what we're going to do is we're going to look at the stats on the table, and it's going to automatically say, look, your stats are out of date, so we're going to go ahead and run an update stats, and then it's going to calculate the cost. And it's going to go allocate the appropriate resources. And that all happens at query time. So if we say, hey, for this particular query, I need 20 nodes, then it's going to go provision 20 nodes in the background. It's going to run your query. It's going to tear those down. If you go run another query, it says, I only need 5 nodes. Same thing's going to happen. It's going to provision 5. It's going to tear that stuff down. You say, hey, I have this really big query that I want to run. I actually need like 50 nodes. Then we're going to go provision those, and then we're going to tear them down. So we give you this concept called bursting. So as your data set grows, you're only wanting to pay for a specific amount of compute. So let's, again, just assume that you're running like an F64 here. We're actually going to give you the ability to use the resources of an F128, we'll say. I don't know the exact numbers, you got them in the docs, but we'll just say you can double the size of the compute resources that you have available. But the nice thing for you is that query actually costs you the same amount of money. So if a query costs 10,000 capacity unit seconds, and it takes 1 hour to run on an F64, we're going to say, you know what, we're going to give you the power of an F128, but we're going to run it in half the time, but we're still going to bill you those same 10,000 capacity unit seconds. So we're able to take this world of the data warehouse and really modernize it and put it at massive scale that we haven't been able to do before. The other thing that we do is resource isolation. So this was a big problem with Synapse and is a problem with contention on any system. But essentially what happens is you've got a single capacity. What you can do is say, I want to actually split this into multiple workspaces. And we'll actually give you a separate dedicated set of compute for each one of those workspaces. So it's as though, in this example, that all 4 of those workspaces are working off their own independent F64 set of compute to be able to give us that scale out or even scale up type of functionality there. So there's a lot of things that we're doing to just help modernize the data warehouse environment inside of Fabric.
Yeah, and after we saw the data warehouse, we start to see that the world is evolving. And as I mentioned, we need to answer several questions with a variety of data, with a need of performance. And to deal with that, we discovered that the relational database was not enough. And because it was not enough, some companies came with the solution that was called the data lake. And that is to overcome the limitations that we saw that exists on the data warehouse in order to be able to process that variety of data in such a speed that we need with the volume that we need. So the data lake, well, in summary, we can say that data lake is a storage. It's a storage based in the Hadoop file system, or HFS. And what it gives to us is the capabilities of be scalable. The ones that are DBAs and work on DBAs in the past know that the hard people to deal with is with the storage guy. Because every time that you need to scale up your database, you need to provision additional systems, and you need to work in a proprietary format that you need to scale your file system. Then you need to upgrade your database files in order to grow in a certain manner. And with the data lake, we are not bound by these limitations. So the promise at that point was, okay, we have a scalable system with a relatively low cost. So we are not going to have the same limitations to deal with the storage guy that we did in the past. It's agile, because now we can put some data engineers and other folks to deal with the data directly without to having like systems to be an interface such as SQL. So now we start to build new professions. So that's when the data scientists start to appear because of the data lake. And with that flexibility, we also give the capability of explore the data better. Okay, we know that SQL is very powerful as a language, but we can do much more when we're exploring raw data at the file system level. But also, with all these promises, we came with a lot of challenges that we know who works with data lake know that we can build up very ungoverned data. So we are starting to lose control what we are putting there. So it's very common to see on some corporations that they are doing the same pattern that is, okay, let's dump the data there, and then we see what we're going to do. And ultimately, it causes some under-standardized data, where we're not saying the patterns, we don't know what it's there. We don't know who put it there, so we start to have security problems. We don't know what we are looking for, because we have just a lot of stuff and a bunch of stuff there, and it starts to become hard to use. So data science can manage that, but business users can use a data lake itself to produce business inputs. Very hard. So, and ultimately, what we start to see, some corporations, we start to see data swamps. We have an area that it's everything there, but we cannot do everything with it. So when we look for those challenges, we start to see that some patterns as well start to appear over these swamps. That is, data movement. Because we start to have silos, we start to see every single department within the corporation and the organization start to have different patterns for different data. We start to move data across the board. And moving data usually tends also to do copying. So we start to copy and move data across different departments on the organizations. And that costs a lot, because it pretty much we are duplicating and charging twice for the same data on the same data lake, and we are moving. And moving data costs money as well, because we need to move, copy, we need to build complex pipelines to do that, and that becomes a big drawback when you're dealing with data lake by itself. But when we look at data lake, and the answer that we have for Fabric is what we can do at a technology level that can somehow overcome such limitations on a technology side, and also provide for the organizations flexibility to build solutions without being impacted by data movement and data copying. So with Fabric, we have one single layer, and the real capability here that is one lake. And one lake is, I used to say that is the core of Microsoft Fabric because it actually empowers us to do everything that I was mentioning on the challenge, and overcome those challenges with technology. But not only that, because when we're talking about one lake, we have one single lake. Who work with Data Lake here? How many storage accounts you guys have? More than one? More than 10? More than 100? So that becomes a pain. Managing different storage accounts with different network solutions, firewall rules, EM rules, that becomes a pain in the neck, let's be clear. And when we look for that, I have customers that I worked with multiple petabytes of data, and this customer actually have 500 storage accounts. That is crazy. And what we build on Fabric is we build really one lake. The idea for one lake is to set the stage for one single data lake that is really the single source of truth for your organization without giving you the burden of managing hundreds of storage accounts, hundreds of network rules, fire rules, permissions between different systems. One lake, that's why I said it's the core for Fabric, because it gives us the capability of handle all this is in one single place. Not only that, because as we were talking about the limitations that we had on Fabric, on Data Lake, we know that moving, copying data, it's produce cost increase, time impact on our solutions, complexity that we know, and we input one new technology with the One Lake that's called shortcuts. In general, what shortcut is for those that are on Unix word, is symbolic links. So pretty much we are creating links for physical files that are on our One Lake, and giving that a logical access for different toolings on our serverless compute solution. So we have different aspects such as data warehouse, data science, as you guys are seeing in different presentations and when we're talking about Fabric. And we can consume everything from One Lake. And through shortcuts, instead of to move and copy data across the board, we can just connect and create links to access this data. Not only that, because we also have a second type of shortcut. We have what we call external shortcuts, that we can create these links for external cloud providers that's out of our One Lake. We can create shortcuts for Amazon S3. We have for Google Cloud coming soon. We can even on Azure create that with Azure Data Lake. And these external shortcuts give us the capability to access data that's outside One Lake as it's local. And it give us the flexibility as well to, instead of to copy everything that is outside on other cloud provider or other system inside One Lake, just copy and transform what we need and bring that for our system. That flexibility gives us also the capability of build solutions without the impact that we normally see on other data lakes.
Right. So who out here has gone through a migration from on-prem to cloud? Okay. How was your experience? Good? If you had a good experience, keep your hand up. If you had a bad experience? Okay. If you had a mediocre experience? Okay. And then there's going to be one person who had a really bad experience. There's a focus group or a room out there where you can give hugs later if you need it. Okay. So when we start talking about the cloud, we're going to breeze through some of this stuff because I want to focus more on the lakehouse piece in here in just a minute. But a lot of the draw of the cloud really came around flexibility and scalability. So we have a lot of the same concepts that you would do on-prem. We're still doing ETL. We're now going to do some ELT instead. We're going to extract and load the data, then transform it to get it off of your on-prem systems. We've got all these new tools like Fabric or Synapse or other services that we can use so that you don't have to continually go out and provision new storage accounts all the time. But it also gives you a lot of scalability that we didn't necessarily have in the prior days. Like you can just go out now and click a button and you can move from a very small Fabric SKU or a small VM or a small Azure SQL DB, and you can go up to a very large one in just seconds in many cases now. So I can go from an F2 to an F2048, the smallest to largest Fabric SKU, and that takes about 30 seconds in order for that to happen, and it's all online. None of your in-flight operations are going to get killed or anything like that. So we just have the ability to go much further. And just a couple of really interesting stats to go along with that. So I was looking up to try to see like how quickly can we load data, for instance, just as one data point. We talked about read performance a couple of minutes ago, but I found that we had this article that we published in Microsoft back in 2006. And it was talking about how in SQL Server 2005, we were able to load 1 terabyte worth of data in 1 hour. And that was like super cool. Like they were very excited about that if you go and read that. Well, if you fast forward in 2019, the Synapse team, we published a blog post that talked about how to load 1 terabyte worth of data into Azure Synapse Analytics dedicated SQL pools in just 15 minutes. Okay, so it's a pretty good increase there. But if you go over to Fabric now, and we look at ingestion speed, and this is into the data warehouse, this isn't like landing data into the data lake. So this is actually putting it into the data warehouse. If you run an F64, you can actually import about 6 terabytes worth of data in an hour with very little optimization or anything. Just splitting up the files and running one thread. If you were to scale the capacity up to an F128, and then you do some work, I'm not going to pretend that this is just a scale to 128 and then go click the button, but if you separate the files out into 1,000 files and you run 3 parallel threads, each loading 1,000 files, that's like the ideal scenario there, we actually found that you could load up to around 34 terabytes worth of data in just 1 hour. So we've gone from 1 terabyte in an hour to now well over 30 terabytes worth of data in an hour. So the performance boost and the scalability that we get out of the cloud is just massive compared to what we've been able to do before. And then as far as accessibility goes, like the barrier to entry now is really just a credit card. You don't want to go run it on your personal credit card. I actually had a teammate that when he started at Microsoft, they give us an internal Azure subscription. And he, for some reason, made the mistake of putting his personal credit card on that Azure subscription, and it went over the limit that we had set internally, and it billed his credit card because he left an HD Insight cluster running over the weekend while he was flying, and he had a charge for $15,000 that he was very unhappy about, and Microsoft eventually refunded, so don't actually put your credit card on there, but that is the barrier for entry, as if you have a credit card. So there are some challenges, of course. There is complexity when it comes to the cloud, on-prem versus cloud connectivity, managing security between the two. You do have to worry about vendor lock-in, like as much as all the vendors talk about how we have this great open format with Parquet, or we're doing it all in some open format, like there is still a level of vendor lock-in. I'm not going to pretend that there's not that reality that's out there. But if we look at how this ultimately plays out with the data platform sitting on Fabric, if we look at a couple of those things that we just talked about, like the flexibility to be able to import data, we have a lot of options. You can use some of your on-prem tooling to be able to load data. If you've got like Golden Gate or something, is Golden Gate still around? Is that still a product? Is it? It is? Okay. Well, if you got something like that, you can actually write the data directly into a Fabric data warehouse. So a lot of the tools now are even supporting dropping the data into a data lake inside of Fabric. We can use Dataflows Gen 2 if you're feeling brave to load data in. You can use a copy pipeline. You can use ADF, like actual ADF, not Fabric Data Factory, to load data. So we just have a lot of different options there. Plus, all that stuff that Freddie was talking about just a minute ago with shortcuts gives us the ability to say, all those folks, everybody that raised their hand a minute ago and said, hey, I've got a data lake inside my organization, we're not telling you, come over to Fabric and move all the data over here. If you want to, that's fine. There's nothing wrong with doing that. But with shortcuts, we have the ability to just point to that data where it sits so that you don't have to move all those 100+ storage accounts that a handful of you said that you have out there. Okay? So it gives you a lot of flexibility that we maybe didn't have on that front before. The other thing that's really cool that we just announced back in January was mirroring. So who's heard of mirroring? Not SQL Server mirroring. Okay. So what mirroring is going to give us the ability to do is say, hey, I've got this system on-prem or maybe in the cloud someplace like an Azure SQL DB or Snowflake if you want to get off of them. Happy to talk. So we've got that on-prem or cloud database already, but we want to copy all that data over here into Fabric. So what we're going to do, instead of you having to go build pipelines and a metadata-driven framework and all that, like that stuff's super cool, but wouldn't it be nice to just go click a couple of buttons and say, copy all this data for me and keep all the data in sync for me at the same time. And it also lands into Delta format in the background so that you still maintain that open Delta format to be able to do your other operations on it. So that's what mirroring is really giving us the ability to do. And you'll see more information come out about that in the coming months. Right now, like I said, we just announced that recently. That's all in private preview. But there's all kinds of cool stuff coming on that front. Yeah. One more time. Great question. Question was mirroring. Does it work with on-prem sources? Not right now, but it will soon. So it's in private preview right now, so there's a lot of limitations on it. But yes, you will be able to connect to on-prem sources or sources that are behind firewalls, virtual networks, that sort of stuff there. Okay. And then the last thing I want to mention here is also some new functionality. Like you'll see over here on the far right-hand side of the screen, we've got this new thing like Data Activator. So if I want to set up alerts whenever I get changes to data, we get all these cool new things that come along with the cloud infrastructure. So in many ways, cloud is a modernization. In many ways, it's getting access to more functionality or scalability. But the biggest thing that's happened recently was the invention or the lakehouse concept that has started to come up. So who out here is working on a lakehouse architecture today? Okay, so quite a few. Who out here uses that lakehouse and consumes data with SQL off the end of that? Like you have users that want to write SQL queries. Okay, subset of the folks. Okay, so what lakehouse, the lakehouse architecture here ultimately promised us was that we were going to get a data lake minus the data swamp piece of it, plus you were going to have the ability to run SQL commands against it, plus you were going to get super awesome performance out of it, plus everybody in here that loves Python is going to be able to run all your stuff against it. And if you like R or Scala or any of that, you're going to be able to do whatever you want on the data. You're going to be able to run your data science. It's going to give you the lowest total cost of ownership ever, and it's going to make the world a perfect place, right? This was what we were sold. Now, to be honest, it does deliver on many of these things. And the way that it delivers on this, as folks are aware, is through the Delta Lake functionality. So that essentially gives us, for those who haven't used this, I'm sure everybody at this point has heard the term Delta by now, or you've heard somebody at Microsoft say Delta Parquet for some reason. But it basically gives us ACID transactions, schema, and all that sort of stuff enforced over top of your data. Now, there are challenges, of course, with the data lake architecture. Now, there's often challenges with speed. This is, I put this on here. I questioned whether or not I should put this on here because there are and there aren't discrepancies between reporting speed. If you start to get into warm cache versus cold cache and how the data is modeled and all that kind of stuff, this isn't necessarily as big of an issue today as it was 3 or 4 years ago on the reporting speed, but it is still something that should be a consideration with your lakehouse. The other thing here is the security side of things. So we have files out there. We then had to figure out how do I do row-level security, column-level security, dynamic data masking, all these sort of things that come along with building analytics solutions and building BI solutions. So again, there's ways to do this depending on where you go with things like Unity and the security model that we're building inside of Fabric and those sort of things. So there are ways to make these things happen, but they tend to not, at least at this point, be as easy or as accessible, I'll say, as some of the things in a regular database engine. And part of that is just because we're also going at the data from different ways. We're giving people access through SQL, but we're also wanting to give access to the actual data files underneath. So there's a lot of questions that you have to ask before you start to build this solution and figure out how it fits into your organization. So when we talk about data lake on Fabric, this is ultimately where we end up with. It looks very similar, again, to many of the other architecture diagrams that you've seen. Again, flexibility on how we bring the data in, whether that's Data Factory, whether that's Dataflow's Gen 2, whether that's Azure Data Factory. But we always still land on this medallion architecture. That seems to be where we come back to. And you can even back into that a bit back in the data warehouse days. Like, we always staged the data somewhere before we brought it in, whether that was an ODS or whether it was a staging database that we truncated. That sort of stuff it's always been in the environments. We're now just solidifying that inside of our architecture and making it more usable than what it probably was in some of your on-prem days. So the question then is, what do we do a little bit differently in Fabric than what you're going to get on some of the other platforms? So the first piece here, well, actually, let me talk about vOrder. So who has heard of zOrder? Okay, who has heard of vOrder, like V, Victory, Vertipack, all that? Okay, so vOrder is the Microsoft compression algorithm that we use over top of the Parquet files. Essentially, it's going to give you better compression, which means fewer logical reads, less data over the network, all that kind of stuff, compared to what you would have if the data was just sitting out there in an uncompressed format, or even over top of zOrder data. We even get better compression there. So a couple of things, just some interesting little statistics here. We saw improvement in read speed by an average of 10% on those on vOrder files, with some of the performance going up to 50% faster using vOrdered as opposed to non-vOrdered files there. The other thing, it does take a hit on write, so you have about a 15% slower write speed that you end up taking a hit on that side, but you also get about 50% extra on the compression side compared to what you get with the non-vOrdered pieces there. So, ultimately, like I said, less I/O, less network traffic, all those sort of things are all super useful for these types of solutions. The other thing is with Spark. So inside of Fabric, the way that we run our Spark clusters, we also have that concept of bursting that comes into play here. So if you remember before, I said you get a multiplier number on the data warehouse side for how much extra capacity we'll give you, even though you're paying for a smaller capacity. So here's how we do things on the Fabric side. If I'm running an F64, I actually get 128 Spark cores. So you always take the number that's on the SKU, multiply it times 2, and that's going to be the number of Spark cores that you get available. Okay? But what we also do is we say we're going to let you burst up to 3 times that amount without having to provision a larger capacity. So it's still going to pull from your utilization whenever you run jobs. However, it's going to give you the extra concurrency that you might not have otherwise. So that means I can actually run 3 Spark jobs in parallel that all need 128 vCores, as opposed to having to run those all in serial back to back to back. Okay? So you get 3 times the number of cores for parallel workloads on the Fabric Spark side of things. Okay? And then we'll go ahead and move on just for time's sake here, but the thing that I want to call out from a Fabric perspective is that the table definition matters a lot. Okay? If you were to load the data into a Fabric lakehouse using the copy activity inside of Data Factory, you would see here that the data types for these 2 columns that are highlighted are string and decimal. And so what that's going to end up doing to you on the other end is it's going to make varchar 8000 field show up on the SQL endpoint, which is fairly terrible. It's also going to do decimal 3818 as the default. So again, fairly terrible, because everything in the SQL side is all cost optimization. And so we figure out how much data is potentially in there, do we need to be able to handle, and we allocate resources appropriately. So you'll see on the right-hand side is the way that the schema should have been built. And you can do that by actually defining the schema and building the schema through a Spark notebook and just clearly defining, go in, do create table inside of a SQL field inside the notebook, and be able to control the data types. And then also, in the future, hopefully we'll be able to give you the flexibility to do that same sort of thing on the data import side. So what the impact that this actually makes for you is about 3 minutes worth of runtime on this particular query. So we went from 8 minutes and 10 seconds all the way down to 5 minutes and 15 seconds by changing nothing else other than controlling the data types on the table that we're loading into. So that piece of it makes a huge difference. It is well worth your extra time. If you have people that are going to be consuming the data through the SQL endpoint, it's well worth your time to go out there and closely define those data types inside of a Spark notebook, as opposed to letting the default behavior create those tables inside of your copy activity through Data Factory.
Then we are again evolving. So we're talking about evolution of analytics. And what it actually means. We are going to talk a little bit of the last guy in the neighborhood, that is a data mesh. Data mesh, of course, is a subject that we can spend a lot of time talking for over one session. So we're going to condensate that on the patterns, because what data mesh is, it's not a technology, but it's actually an architecture, a paradigm that we want to try to solve some of the problems that we saw with the data lake, with the segmentation, with multiple different lake houses and data houses across the organization. So what it is, in summary, is we are jumping back for the idea that having a centralized organization from the perspective of data is not good. Because we are saying that one single team handling everything regarding from pipelines, from reporting production, all the way to the user experience is not good. And someone came with the idea that instead of to work on that, let's do something different. Let's create domain-oriented organization, meaning that we are going to have the departments, the people that is actually producing that data, handling that. And with that, we are going to work with some aspects of the data, different than we do with Lakehouse, with Data Warehouse. And we do that by approaching data as a product. So we sell, we put our product out even within the organization. And as we treat that as a product, we start to see and create a culture of a self-service organization. So I'm putting the product there. I'm curating, I'm creating my data set, I'm putting it available for other departments, but the other departments should be able to consume that data without I be engaging with them in daily basis. So with that, it's expected to have a more dynamic and easy environment to address some of the business questions that we need to deal with data. As we saw, we talk about data swamp, data movement. We saw about the limitations that we have with regular data lakes. I have one customer with a successful implementation with data mesh. They had 15 petabytes of compressed data. These go towards 500 storage accounts. They have several. By several, I mean over 10,000 of pipelines to deal with different business lines. And the business lines just need to communicate each other. With one single data lake and one single data team, they work crazy. They were not able to deliver what business need in the speed that the needs demands. So what we start to see with adopting data mesh of that organization is the teams, after a 3-year implementation, get a more dynamic experience. They could produce and engage with data. Does it hurt to implement? It does. Because there's a lot of culture aspect, not technology, that we need to work. Because we need to have people that are specialized in building pipelines, working with Spark on the marketing team. Marketing team knows nothing about pipelines, but they will need to have someone. They will need the business team will need, the procurement team will need. So what happens is we start to have more specialized team across domains to build up those pipelines. But in the long term, as we moving towards that, it tends to be successful. But that's also not just a blue sky. We have a lot of challenges. And the first one is there's no such thing as standard for data mesh. Because we are going to find organizations that are trying to implement data mesh, and ultimately you're going to see different flavors, how they adapt data mesh for their reality. So it's very hard to have one single formula that's going to fit for all. It will require a lot of investment, because you need to train people. You need to change behaviors, change mindsets. So for this customer that I mentioned, we're talking about implementation that took 3 years. Long story short, we need to work towards training, a lot of training, because people that are implementing pipelines, they need to be trained to produce the same quality of work. Because when you have different people, different skill sets, you can build different quality of work, and it tends to impact also the experience with a data mesh. So
question then is, what's the answer? So I mentioned at the beginning, I was a consultant for 6.5 years before I came to Microsoft. So I'm well versed in the answer of it depends. There are a lot of different options. There's a lot of different pieces to this puzzle. There are a lot of different complexities with every single person's environment. Ultimately, I think the answer to this is that you have to mix and match the pieces that make sense for you. We talk to people all the time that say, look, I don't want to let go of my T-SQL skill set. My people on my team, they love their T-SQL. I go to other customers and they say, look, my whole team, we want to start doing things a new and modern way. We want to just use Spark first for everything. And we want to, we're hiring a bunch of people with Python skills. And so for them, maybe it makes more sense to go over to a lakehouse type of architecture, but still have that SQL endpoint to be able to enable the business users to be able to come over and get the data from the T-SQL endpoint. The size of your data is probably going to make some sort of difference in this too. I mean, data warehouses, as you saw when we talked about, we scale quite well with those. But if you do have those petabytes worth of data that you need to churn through, then a data warehouse by itself maybe is not the right answer. That doesn't mean a data warehouse isn't a portion of that answer. It certainly could be a piece of the puzzle. But if you're dealing with streaming data, for instance, a data warehouse is going to do you almost no good. You need to go look at something else. And that's where some of the other stuff in Fabric come in. Things like the KQL, or the real-time analytics experience with event streams that can land the data into the lakehouse, which you can then use Spark to go out and process. So there's a lot of different options out there between all of these different architectures. And again, I think the right option for you is really going to be a mix and match of these. And you're going to, maybe eventually in the future, we end up in a spot where everybody in the room says, look, we are 100% on the cloud. But I think we're a long way from that. So we're going to have to deal with things like shortcuts, mirroring, ETL processes to get data off of on-prem networks, and ultimately build these hybrid solutions that span across the warehouse, the lakehouse, and ultimately build some sort of a data mesh type solution in the future. So with that, any questions in the last minute and a half, 2 minutes that we have here? We'll be around for the rest of today, tomorrow. If anybody has questions, wants to chat about any of this stuff, have questions or anything, would love to talk. But any questions for right now before we wrap up? All right, I have stickers. If people want stickers, everybody loves a good sticker. So if you want a sticker, come up and see me. Freddie, if you can put, thank you slide, fill out the survey. Let us know how amazing and wonderful everything is, and enjoy the conference.